One other skill we learned that had to do with exponent rules was converting to and from scientific notation and decimal notation. So we're going to convert these two. Remember, very large numbers will have a power of 10 that's positive. Very small numbers will have a power of 10 that's negative. Alright, so we know that this one will have a positive power of 10. So we rewrite this taking the digits 2 and 3 because it has nothing before it, only zeros after it. So the digits 2, 3, and we place the decimal there so that it's between 1 and 10. So 2.3 is a number between 1 and 10. We multiply that by a power of 10 that moves the temporary decimal here back to where it really belongs here. So how many places is that? Well, that's 1, 2, and then 3, 6, 9 more, 11 places it looks like to me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Times 10 to the 11th power. It's a positive power. Right, now this is a small number, but the process is much the same. So we find the digits 726 because only zeros before it, nothing after it. So we write 726 and we place the decimal after the 7. That makes it a number between 1 and 10. We multiply that by a power of 10, 10 to a power, that moves the decimal from here back to where it really belongs, here. So that's to the left, 1, 2, 3, 4 places, which makes our power negative 4. Right, we can convert the other direction as well. We can start with scientific notation and move to decimal notation. We just follow the directions of the power of 10. So we take our digits 825. We know it's going to be a large number. We know we're going to be adding zeros to the other side. 825. Now we need to move it 2 places to the end here and a total of 7. So these 2 places for a total of 7 means we need 5 more places, which means we need 5 zeros. So that would move it from here 1, 2, 3, 4, 5, 6, 7 to the right, and then place commas where they belong. And here we know we're going to have a very small number with zeros in the front, so I might start my number over here to have room for zeros in the front. So take the digits 5191, and I know the decimal was temporarily placed here after the 5, and it needs to go 8 places to the left. So it goes 1 place to the left here, and it needs to go 7 more places for a total of 8. So 1, 2, 3, 4, 5, 6, 7 ought to get it. 1, 2, 3, 4, 5, 6, 7, 8 places. And we often put a 0 in the front to hold the 1's place. Okay. Scientific notation and decimal notation. Alright, now, introduction to polynomials. We have evaluated expressions before in this class. Now we're just calling them polynomials. We can still evaluate. We have variables x here, and we want to evaluate the polynomial for x equal 3. That means we go find all of the x's and replace them with the value 3. 3, instead of x cubed, we have 3 cubed, minus 5 times, instead of x squared, we have 3 squared, plus, instead of x, we have 3. And now we just do the math in order. We always carry out our exponents before multiplying. So this 3 to the 3rd power, 3 factors of 3, 3 times 3 times 3, 27, minus 5 times 3 to the 2nd power, or 2 factors of 3, is 9, plus 3. Now we have multiplying to carry out before we can add or subtract. So we have 27. Negative 5 times 9 is negative 45, plus 3. And let's see, when we carry out the addition and subtraction here, let's see if we do 27 plus 3 is 30 minus 4, it should be negative 15. Alright, now we could evaluate the same polynomial for a different value of x. Let's say evaluate the polynomial for x equal negative 3. Alright, so the process is the same. except this time we're replacing every x with negative 3. So we have negative 3 raised to the third power minus 5 times negative 3 squared plus negative 3. Alright, now we take care of our exponents first. 3 factors of negative 3 comes out negative 27. Minus 5 times 2 factors of negative 3 is positive 9. Plus a negative 3 we can just say is minus 3. Right? Now we have multiplying to carry out before we do addition or subtraction. So we have negative 27. Negative 5 times 9 is negative 45 minus 3. And carrying out all of the subtraction here, I believe we have negative 75. Okay, you can check that with your calculator. I believe that's correct. Alright, so that's evaluate polynomials for a given value of your variable. Another thing in Introduction to Polynomials is that we learn to collect like terms and arrange in descending order. So here we have a list of terms, a collection of terms in a polynomial. In descending order means from the highest power to the lowest. So we look at our variables. We have x to the understood 1 power, x to the 3, x to the understood 1, x to the 3, and no x's. So I'd start with the highest powers of x, which is x to the 3. I see 2 of those terms, and I could go ahead and add those. Positive 9x cubed, positive 7x cubed. When we add 2 like terms, we get a like term. So by adding those coefficients, 9 plus 7 is 16, like term x cubed. Also, negative 5x and negative 2x are like terms because of their like variable parts. So we're going to add those together to get a like term, negative 5x, negative 2x for negative 7x. And that takes care of these two terms, Plus 4 has no like term to collect. And we have collected like terms, and our result is in descending order. Alright, can we identify the degree of each term? Remember, the degree of each term is the sum of the exponents on the variables. Okay, how many terms do we have here? 1, 2, 3, 4. And each term has a variable part, except for this one, it has no variable part. So if we identify the degree of the first term, it's only one variable, so the degree here is 3, the degree here is 2, the degree here is 1, and because there's no variable here, it would be x to the 0 power. That is degree 0. For the same polynomial, what's the degree of the polynomial? We listed the degree of each term. And remember, the degree of the polynomial is the highest degree of the term, so of the polynomial. The highest degree of any term here is the degree 3. So the degree of the polynomial is 3. Alright, let's identify the degree of each term here. Now each term here, some of them have more than one variable. This one has 2 variables, and remember, it's the sum of the exponents on the variables. So this has an understood 1 plus 2 for degree 3, an understood 1 plus 1 for degree 2. This only has one variable to an understood 1 power, degree 1. This has no variable, so it's x to the 0 power, degree 0. And so what is the degree of this polynomial? Again, the highest degree here is 3. Let's classify these polynomials by number of terms. Classify each polynomial by its number of terms. Remember, we have special names for certain kind of polynomials. So this one, let's count terms here. 1, 2, 3 terms. And we know that a polynomial with 3 terms is called a trinomial. Count terms here, we have 1, 2. We know that a polynomial with 2 terms is called a binomial. Alright, and here we have 3 variables, but it's only one term. Remember, these 3 terms were connected by addition or subtraction. These 2 terms were connected by addition or subtraction. There's no addition or subtraction connecting our variables here, so everything is connected by multiply. That means it's only one term. So we know that a polynomial made up of only one term is called a monomial.